All right, first step good?
Yes.
Yeah.
How about the second step?
Yeah.
Yep, so the factors are nice?
Yeah.
No.
No. Right, because if you were to multiply your outer values here, you would get 3x, right? The inner values would give you negative 4x. 3x plus negative 4x gives you what? Negative x.
Uh-oh.
All right, so that's where we run into the problem.
Not cool.
So in this step, we have the issue. So that's what we have to figure out. So let's do our x chart. We'd be looking at negative 12 up top, negative 11 on the bottom. So I need two values that multiply to negative 12, that
12 and 1.
negative 12 and 1. Boom shakalaka, of course. So we're looking at 3x squared minus 12x plus 1x. You don't have to write the 1 if you don't want to. Minus a 4 equals 0. All right, group it. So pull out the 3x on the left-hand side. You'll have an x minus 4. Bless you. We know that we also have to have an x minus 4 on the right-hand side, which means that the coefficient for that has to be a plus 1. Don't forget the plus sign. Easier said than done, I think, but... All right, so yank out the x minus 4, and you'll have a 3x plus 1. All right, so all of that was last unit. The next step is this unit. All right, so this is the only new part of it. Set each of these factors equal to 0. And solve, and you'll get x equals 4. And for the right-hand equation, I have to subtract a 1 and divide by 3. So x would be equal to what? Loud and proud. Negative 1/3. Right? You're subtracting 1 and dividing by 3. So you'd have a negative 1 on the right-hand side. Then you divide by the 3, and you'll make that negative 1 into a negative 1/3.
Okay.
All right? So those would be our solutions. And we talked about this last class. It really is just a matter of how you prefer to write it. And you know what my preference is. As complicated as possible, of course. X such that x is equal to negative 1/3 or 4. All right. That'll never be the mistake in a question like it is. Not designed to be a trick question. Like the notation of your final answer is not as important as I make it out to be. I just think it looks really cool. Like you look at something like that, it looks really, really fancy. We like something like that. If you have your program functioning fully armed operation.
Oh my god. You saw it.
I just heard.
Yeah, me too.
You did.
Yeah,
It's like that. Yeah. I didn't hear it.
I still
I
hear
have,
it.
looks like I have supersonic hearing.
Wow, a little Superman 1 action there. So program, I have a ton.
Oh, really?
Until I have a fair amount of time on my hands. So QF, pop in the original problem at a coefficient of 3, negative 11, and negative 4 when it was in the proper form. And so you get that. So it's pretty easy to see, well, the 4 is obvious, but it's pretty easy to see that you have a fractional answer. Whether or not you recognize that as negative 1/3 is a different story, but it's pretty obvious you have a whole number and a fractional answer, so at least you know what you're up against. All right? Sometimes, and this is a good resource, sometimes you could use your answers to kind of steer you in the right direction when it comes to finding your factors. Right? So the fractional, so the reason I say sometimes, if you get two answers that are both hideous decimals, that's the other part of sometimes, the part where it's not going to help you. But this gives you a nice clue because I know that one of the answers is 4, which means that one of the factors has to be x minus 4. All right? So I already know one of the factors, so I could piece together what the other factor is going to be just by that knowledge. So that's pretty useful resource. And in fact, it would have been a even better resource in the last unit. Because if you don't know how to factor, this is great stuff, the calculator. Because if I'm telling you that you have 3x squared minus 11x minus 4 equals 0, and then I'm telling you, it's like those area problems in the last unit. I'm telling you one of the factors is x minus 4. Off the bat, just by knowing how to use the calculator, the program that you wrote yourself last week. All I'd have to do is figure out what I have to multiply x by to get 3x squared, so 3x. What I'd have to multiply negative 4 by to get a negative 4. So a 1. And I would have the other factor without having to know how to factor. That's what I was waiting for. Thank you. Acceptable. It was the pronounced whoa. Aw. You gotta let me believe these things. You can't just shoot me down like that. Well, in actuality.
I believe they have the same meaning.
Okay. Interchangeable?
Yeah.
Alright. I'll allow it. So, x squared equals 6x. Oh, it went off the rails immediately. What was the first mistake? They didn't subtract 6x. All right, so this one's going right back to scratch. So we're looking at x squared minus 6x equals 0. Let me just put it to you this way. If you're solving a quadratic and not using factoring at some point in the process, you're probably doing it wrong. All right, so if you solved a problem and you're like, oh, this is great. I didn't have to use factoring one bit in this entire problem. Just assume that you botched it up. All right? So factoring has to happen. The only time it won't happen is when you use the program, the quadratic formula technique. All right? So what type of factoring makes sense here? That's just awesome. Right idea, because you're thinking, I assume there's two things, one of which is a perfect, the other is not a perfect square, so we have that issue there. But, I mean, your mind's taking you in the right direction. Unfortunately, it's not quite. GCF, yeah. Always ask yourself, is there a GCF? Because it should be the first thing you're taking out, if it exists. So then set each of your factors equal to 0. And you get x equals 6 as one of the solutions, but the person who attempted this problem initially lost the x equals 0 solution. Is it important? Of course it is. Why? Who knows? We don't have any context yet. So we don't know why it would be important. We just know that it could be important, and so we can't just dismiss it as a possible answer. All right. And in fact, 0, I mean, you're gonna find as you go through math and science that 0 is the most popular number because it's talking about the initial value in most cases. So it's the starting point for almost, well, I'll say almost everything, because sometimes 0 is not the starting point. Something is happening prior to you starting the clock. I use the analogy of a person running around a track. You know, if the person is on the starting blocks at time t equals 0, then 0 has meaning as the start of the event. But if the person's already in motion, and then you start the clock after, let's say, they completed their first lap, then negative 20 would have meaning because it's just 20 seconds prior to you starting to keep track. Or maybe you hit the lap button on your calculator, on your phone, you know, because if you ever use the timer feature, there's the overall timer, and then you can lap it. So you can get the particular intervals. So if that's the case, -20 is just 20 seconds prior to that lap being completed. So it does have meaning. 0 is not your starting point. Overall, it's just a starting point for that particular lap. All right. So 0 could be, in this particular problem, whatever it's related to, it could be the only answer that has meaning. Maybe the 6 doesn't make sense in the context. Maybe it's the 0 we care about. But in solving it this way, we lost the 0. So perhaps you come up with an answer that makes absolutely no sense. You know, when we've all been there, hopefully not the subject of this, but we've all been in a room when it happened. Teacher says, all right, what's 2 + 2? And somebody yells out 7. And you're like, whoa, where did that come from? You know, that could be the case with the 6. It could make that little sense as the final answer. Like, it could be completely absurd as a final answer. So you don't want to lose the 0. It's so important. All right. So the last one. Oh, okay. So I'll put it to you. Where did this person go wrong? Step 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5.
They didn't double divide. I mean,
What?
I mean, no. They didn't square the x. They just went right to the x + 2.
It just went right to these set of factors without any rhyme or reason as to why that would be the case. If we check this, by double distributing, we would get 2x + 2x, which would be a 4x, which is not included here. All right? So in this case, we're looking at something that's not factorable. Therefore, 3 dots in the form of a triangle is a cool way of representing the word therefore. No real solution. Got to have the word real there for this to be a correct answer. You don't want to say no solution because there are solutions. There's plenty of solutions. They're just not real. If they're not real, what are they?
Fake.
Fake. Totally.
Wait, how would you not do like difference, like the perfect square thing? 'Cause, like,
I think you just answered it. Difference of perfect squares. Difference implies what operation? Addition or subtraction? Subtraction. Right? Can't be a difference of perfect squares if there's no difference, right? Yeah, that's got a sum. Sum of 2 squares, and don't feel bad about that because I tried warning everybody before the last test. I even gave you an example of what I was going to do on the test, and then I followed through on that example. And still half the class got it wrong. So what I did, I don't know if you remember the moment, but I said I was going to put a problem like, what is x + 4 times x + 4, which was, I believe, question 2. And the correct answer would be x squared + 8x + 16. And then later on in the test, so this is something like question 7, I said, what are the factors of x squared + 16? One of the choices was x + 4, x + 4. Could not have been the case, right? Because if this distributes to this, then how could this have the same factors? It's not the same polynomial. The correct answer would be no solution. There were no factors because this was a sum of 2 squares. All right, so warned you about it, followed through on the warning, still half the class blew it. All right, and also, folks, if you're ever in doubt, use your calculator. And I don't even mean the quadratic formula program. X squared + 4 equals x + 2 x + 2. 0 means false. 1 means true. 0 is saying that it's true 0% of the time. One is saying that it's true 100% of the time, so true and false. All right? It's telling you clearly that this is a false statement. Okay? But it's not going to tell you anything if you don't know how to use that function on your calculator. Just reflecting back on the course so far, you might look at all these little calculator tidbits as luxuries or fun facts of the day. The day of the regents, for a lot of us, it's going to be the method by which you're going to get the majority of your multiple choice questions correct using the calculator. And also, let's say you are completely anti-calculator, which, you know, I teach at the college, and some people, especially those coming from foreign countries that are a little older, they only learned everything by hand. So this whole calculator business is like insulting to them. They're like, how can you demonstrate knowledge of math if you're letting a calculator do the work for you? And so it takes a while for them to be convinced that the calculator is a resource, not a way of just doing the work for you. In all cases, it's a good learning tool. So I do have to deal with that resistance. But eventually what happens is they take a test. The people who listen to me and use the calculator like they should, they're done with the test in 15 minutes and they get an A. The people who don't, they're done with the test in 2 hours. Still get an A. They're doing everything by hand, but it takes them 2 hours. So 8 times the length of the person who's using the calculator. Now that actually might work against you the day of the Regents, because you use the calculator, you're done with the Regents exam in 20 minutes, then you gotta wait an hour and 10 minutes before you can be dismissed. So you go to the bathroom like 7 or 8 times. So that's the one drawback. You might be finished way earlier than you wanna be. So you might be like, oh, maybe I'll do a bunch of these by hand and check it with the calculator just so I can kill some time. But that is really the only drawback. So please listen to me when I show you these calculator shortcuts. All right? That was so important, I had to make sure it was on.